Okay, so AQA paper 1, set 1, test paper. So the first question then, let's go through this. So 1A, what is a fifth as a percentage? Percentage is out of 100, times that by 20, times the numerator by 20. 20 out of 100 is 20%. So our answer is going to be the one on the end. 1B, what is 0.9 as a percentage? Okay, there's different ways that we could do this, but hopefully you know that to go from a decimal to a percentage, you just times it by 100. Times it by 10, you get 9. By another 10, you get 90%. Number C, in fact, number 2. Okay, so number 2. There are 20 students. So we've got 20 students. 12 are boys, so we're going to have 8 girls. What fraction of boys? Well, it's going to be 12 out of 20. And we look and we see that none of them are 12 out of 20. So what we need to do is we need to simplify it. So half the top and the bottom, you get 3/5. Okay, number 3. Simplify this. So we've got 7x plus 5 minus 8 minus 3x. Okay, so what we've got is we've got 7x, take away 3x, which is 4x. 5, take away 8 is minus 3. So with these questions, it's really important that you circle or you get the sign in front of the number that you're given. Okay, number 4. Rattling through this. So we've got a bar chart. We've got 25 students and it says draw a bar chart to show this information. Nice and straightforward. So we're going to start at 0. And then the first thing that I'm going to do is I'm going to look at my scale. So looking at the graph, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. Walk is the highest. So actually I'm just going to go up in ones. So 5, 6, 7, 8, 9, 10. So I'm just going to go up in ones. So 2, 4, 6, 8, 10. Because I've not got much room, I'm not going to fit all of the others in. But you've got the idea. Each square is 1. So for walk, I'm going to go up to 9. And you need to make sure that you've got the same width. So I'm just going to have 1 bar for walk. I'm going to leave a space of 1 gap. And then I'm going to do bus, which is 8. So I've got equal widths of the bars and equal widths of the gaps. Car is going to be 7. And then we've got taxi is 1. So we've got taxi here, which is 1. Happy days. Number 5. Okay, so number 5. Here are the events for an ordinary fair dice. Roll an roll an odd number as A, roll a number greater than 6, blah, 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 blah. Draw and label arrows to show the probabilities of events B and C. So with probability must be between 0 and 1. 1 is certain, has to happen, and 0 is impossible. If you flip a coin, heads and tails, that's going to be 0.5 or what we call even chance. So on a dice, we've got a normal dice, 1, 2, 3, 4, 5 or 6. The first one, in fact we've got A, haven't we? A is there, so we just need to put B and C onto the diagram. So B is roll a number greater than 6. Well, that's obviously impossible, so we're going to put our cross there. In fact, it says draw and label arrows. So I'm going to read the question and I'm going to put B. And then roll an even number less than 3. Well, that's only going to be 2. So what is that as a probability? Well, it's going to be 1 out of 6. So 1 out of 6 is going to be, luckily, we've got them in 6 different sections, haven't we? 1, 2, 3, 4. Perfect. So it's just going to be, so what have we got? 1, 2. So it's going to be here. Okay, so that is C. Okay, number 6. Just put that on the screen. So number 6, 23.7, subtract 2.5 times 8. Be careful, we've got BIDMAS. Okay, so we've got BIDMAS. So multiplication is first. 2.5 times 8. How are we going to do that? What I'm going to do is I'm going to do 2 times 8 is 16. Half times 8 is just half of 8, which is 4. So 2.5 times 8 is 20. So then my question is 23.7 take away 20, which is just 3.7. Number 7. Write these numbers in order, starting with the smallest. So with these questions, what I would suggest is that you look at the number with the most number of digits after the decimal place. Okay, so with this example, our first number has 3 digits after the decimal place. So I would make all of the other numbers have the same number of digits after the decimal place. So this one I'm going to have to add 2 zeros. This one I'm going to add 1 0. This one I'm going to add 1 0. And then you can just see, well, they all start with 2. We've got to put them in order starting with the smallest. So 30 is the smallest, so 2.030. Then 300, then 300, so we've got 2.300. Then we've got 2.303, and then we've got 2.330. Okay, so we don't even have to change them back to the numbers that we were necessarily given. We can just give it like this. So just remember that trick. Make sure you've got the same number of digits after the decimal point, and then it's much, much easier. Okay, 8. There are 25 counters in a bag, so we've got 25 counters in a bag. 12 are red, 5 are green, and the rest are white. So let's just work that out. That's going to be 17. 25 take away 17 is going to be 8. So we've got 8 white. The counter is chosen at random. Work out the probability it's white. Well, I've just worked it out. So it's going to be 8 out of 25. Does it say to simplify it? No. So I can just leave it like so. 9. 110 students go on a trip. Each student needs a bottle of water and they're sold in packs of 6. How many of these packs are needed? Okay, so we need to work out how many 6s go into 110. So hopefully you know that that's just going to be bus stop division. How many 6s go into 1? 0, carry the 1. How many 6s go into 11? 1, remainder 5. How many 6s go into 50? If you're struggling with your times tables, just write them out. Right? You don't lose any marks. It'd be sensible to just write them out. 8 6s are 48. So I'm going to have a remainder of 2. 6s into 20 is 3, remainder 2, 3, and so on. So actually 110 divided by 6 is 18.3 recurring. But be careful, okay? How many of these packs are needed? Well, if 18 packs, we're going to have a little bit left. So we have to get 19 packs to ensure that everyone gets a bottle of water. Okay, so just be careful with that. It might be, for example, you might have, I don't know, number of buses, and you might work out that you need 3.4 buses for a school trip. Well, obviously you're not stupid. You know that you can't hire 0.4 of a bus. So you're going to have to round it up to get an extra bus, or in this case, an extra pack of water. 10. Oh, I like these questions. So, number 10. Angles on a straight line. That's 41. This angle here is 27. We're asked to work out the one in the middle. I've called it Y, they've called it X. Work out the size of angle X. Well, angles on a straight line add up to 180. So we're just going to do 180, take away 27, take away 41. The way that I do it, you might have a different way. What I'm going to do is I'm going to add them together. 27 add 41 is 68. I would then add, how many do I need to add to get to 100? Well, I need to add 32 to get to 100. I then need to add another 80 to get to 180. So I think the answer is going to be 112 degrees. Okay. Okay, next piece of paper. So, what question are we on now? Number 11. Here is a centimetre grid. Okay, so here is a centimetre grid. A is 3, 5, blah, 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 blah. You must show your work image maybe on the diagram. What type of triangle is A, B, and C? So let's see if this works here. So I'm going to see if I can draw this diagram. So we've got our X and we've got our Y. Now with coordinates, it's along the corridor up the stairs. So A is 3, 5. So let's see, 3 across, 5 up. All right, so I'm just going to put 3, 5 there. And that's going to be point A. B is 0, so 0 left or right and minus 3 down. Okay, so that's going to be B. And then C is going to be minus 5, 2. Okay, so we've got minus 5, 2. Either here it's going to be C, and this point is 0, minus 3. What type of triangle is it? What are they suggesting here? I think I probably have to do a bit more work to work this out. Hopefully it'd be easier. I think that that is one where those two lengths are the same and this one is different, which would be an isosceles triangle. Okay, let me just check the mark scheme on that one. Hurrah! Okay, so we've got that one. Right, number 12. So, number 12, right, this looks fairly straightforward. You just got to learn these basically. So, 2 to the power of 4 to the power of something just means you multiply it by itself that many times. So, 2 times 2 is 4, times 2 is 8, times 2 is 16. Part B. Circle the value of 5 to the power of 3, and if we've got to the power of 3 we just say 5 cubed, so we've got 5 times 5 times 5. 5 times 5 is 25, multiplied again by 5 you get 125. Part C, the square root of 196, you've just got to learn these, okay, so most people can get to 12 times 12. 13 squared is 169, 14 squared is 196, 15 squared is 225. So this is going to be 14. 13. So we've got 13. So solve 4x minus 5 equals 17. Whatever way you solve equations, okay? So we're going to try and find what 1x is. So I'm going to add 5 to the left hand side. I need to do the same to the right. 17 add 5 is 22. Minus 5 add 5 is nothing, so we're just left with 4x. I can then divide both sides by 4, and I get 1x is 22 divided by 4. Okay, doesn't ask me to simplify it, doesn't ask me to leave it as a decimal, so in fact I'm just going to leave it like that. Just going to leave it as 22 over 4. Okay, 13. In fact, was that 13? We're on to number 14. Okay, John has 78 pence. Nat has £3.52. Nat gives John some money so that they both have the same amount. How much does Nat give John? Okay, so Nat gives John some money. Well, what I'm going to do to start with is I'm going to add up their money. So £3.52 add 78. How much do we have in total? 8 add 2 is 10. 7 add 5 is 12. Add the 1 is 13. So together they've got £4.30. So for them to both have the same amount of money, they must have half of that, which is going to be £2.15 each. So how much does Nat have to give? Well, we need to work out the difference between these two. So again, I'm going to work up because that's just kind of how I do it. So there's 100 pence in a pound. So I'm going to need 85p to get to £3. I'm then going to need another 52p to get to £3.52. 80 add 50 is 130. 5 add 2 is 7. So that's going to be 137 pence, but they want it in pounds, so it's going to be £1.37. Okay, and you could check that. £1.37 add 78 is going to be £2.15. So yeah, I'm fairly happy that we've got that one correct. Okay, number 15. So let's have a look at this one. Cinema, how my word, 6 marks. Here it goes. So 37 rows of seats, 23 seats in a row. Adult tickets are £8. Child tickets are £6. The cinema sold tickets for every seat. Okay, so we sold all of them. Manager estimates that £6,400 was raised from these tickets. 200 child tickets were sold. Check with the manager's estimate. Blah, 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 blah. Right, there's loads to do, yes. So break it down. When you've got a question like this, rather than just go, oh, it's 6 marks, I'm just going to move on. No, break it down. There's 37 rows and there's 23 seats in each row. So you want to do 37 multiplied by 23 to work out how many seats there are. So we've got column multiplication. 3 times 7 is 21. 3 times 3 is 9. Add the 2 is 11. Now we're multiplying by the tens column. I'm going to put my 0 as a placeholder. So 2 times 7 is 14. 2 times 3 is 6. Add the 1 is 7. And then we add these together. So you should have, hopefully, 851 seats. Adults is this, children is this. Well, we know that we've got 200 child tickets. So 200 times 6. How would we do this? Well, I'm just going to do 2 times 6 is 12 and then add the 2 zeros on. Right, so we've got 1,200. Now, we sold all of them. So if there's 200 child tickets being sold, how many adult tickets? Well, it must be this difference here. So we must have 651 adult tickets being sold, and they're sold for £8. So this one is a bit more awkward. So I'm going to do column multiplication again. So 8 times 1 is 8. 8 times 5 is 40. 8 times 6 is 48. Add 4 is 52. So we've got the money from the adult tickets is 5,208. So if we add these together, the total is £6,408. And it says the manager estimates that £6,400 was raised from these tickets. Check whether the manager's estimate was close to the exact amount. So you must answer that question. Is that close to £6,400? Yes. Answer close to manager's estimate. All right, done. Number 15. In fact, what are we on? Number 16. Okay, this one's slightly harder because I've not got it printed in front of me, but let me just explain how you do it and hopefully that makes sense. So we've got 1 centimetre represents 80 kilometres. Okay, so 1 centimetre on the map represents 80 kilometres. 16A. What is the 3-figure bearing from Lyon from Bordeaux? Now with bearings, okay, there are only 3 things that you need to know about bearings. The first one is that they're always measured from north. The second thing is that they're always measured going clockwise. And the third thing is that they must be 3 digits. So if you look at the map, we're going from Bordeaux. Okay, so we're starting from Bordeaux. And loads of people make that mistake. So if we look at the map, Bordeaux is here. Okay, so we've got Bordeaux here. And Lyon is over here. So what's the bearing? Well, we're going from Bordeaux. I must go north. In fact, I must go from north because that's how we do it. I'm going towards Lyon and I'm going clockwise. So what is that angle there? Well, we know that it must just be a little bit less than 90. So let's see if we can just look and work that out. It must be a little bit less than 90, so it's going to be 0.85. Okay, can we fit B on the same page? Work out the actual straight line distance from Paris to Marseille. So this one's going to be hard to do without it printed. But Paris to Marseille, what you need to do is you need to measure the length really accurately from Paris to Marseille. Okay, and that will give you a certain number of centimeters. I don't know, let's just make it up and say, what are they going to give you? Is it going to be something easy or is it going to be something difficult? What have they given you? Okay, I think they've given you something a bit awkward. So if you measure that and you get 8.2 centimeters, how are we going to work that out? Well, 1 centimeter represents 80 kilometers. So we can just times them both by 8 to get what 8 centimeters is. So 8 times 8 is 64. So that's going to be 640. But what's 0.2 of a centimeter? Well, what I'm going to do is I'm going to divide it by 10 to get 0.1. So 80 divided by 10 is 8. So therefore 0.2 centimeters must be 16. So then 640 add 16. Our answer is going to be about 656 kilometers. Okay, what are we on now? Number 17. So, number 17. Here is some information about a group of children. So let's just write this out. Boys, girls, left-handed, right-handed. Boys is 3, girls is 8, and we've got 12, and we've got 20. So the question says, write down the number of left-handed girls to right-handed girls as a ratio. So left-handed girls is 8, right-handed girls is 20, so we've written it as a ratio. But it says simplest form, so we can halve this one, halve this one, halve this one, halve this one. So it's going to be 2 to 5. B, what percentage of the boys, so we're only concerned with the boys, and there's 15 of them, are left-handed. So left-handed is going to be 3 out of 15. We can simplify that to 1 out of 5, but I want it as a percentage. So remember, a percentage is out of 100. Times that one by 20, times that one by 20, 20 out of 100, 20%. C. Liam says, if you divide any multiple of 10 by 2, the answer always ends in 5. Is he correct? Write down a calculation. So if you divide any multiple of 10 by 2, the answer, well, let's do it. 10 divided by 2 is 5, so that works. 20 divided by 2 is 10. Well, that doesn't end in a 5, so that doesn't work. So is he correct? No. 20 divided by 2 is 10. Odd question. That was what? In fact, it wasn't 17C, was it? It was 18. So, number 19. Translate, blah, 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 so that point A moves to point B. Right, nice and straightforward. So, A looks like so. B is over here, so all you've got to do, translate just means move it. So move that to there. You've got exactly the same shape. You just moved it over there. 19B. Okay, so it says rotate, blah, 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 blah. So C is this one. And then we've got D here. So rotate the triangle 90 degrees clockwise. So what I would do, it's quite difficult to show you here. If you're rotating a shape, it's always good to use tracing paper. Put tracing paper over the shape. Draw an arrow facing north. Now, if it's going 90 degrees clockwise, what I would do is I'd put my pen on the tracing paper and I'd rotate. So if I put my pen here, I'd rotate the tracing paper around 90 degrees so that the arrow would end up facing to the right. And once it's faced the right, what you'd see is that you'd see your triangle look something like so. Okay, so that has been rotated 90 degrees. Okay, up here then. So what have we got? Number 20. Unless there's another part. Blah, blah, blah. Right, so we've got V equals half x squared h. Work out the value of V when x is 11. Funnily enough, you get 1 mark for just doing this. Half times 11 squared times 6. So we've just substituted those numbers in, and then you just got to work it out. So we've got half of 11 squared is 121 times by 6. You can do this in any order. So rather than doing half of 121, I'm going to do half of 6. 3 times 121 is 363. 21. Diaries are sold in boxes. So diaries in boxes of 12. Pencils are in boxes of 10. Rulers are sold in boxes of 6. Okay, right, fine. Teacher wants to buy the same number of diaries, pencils and rulers. Work out the smallest number they could buy. So this question is working out lowest common multiple. So what's the lowest common multiple of all of these? Well, what are probably easiest is just to write them out, to be honest. I mean, there is a quicker way, but it kind of makes more sense to just do this. So we've got 12, 24, 36, 48, 60, 72, 84, 96, and so on. 10 times table is just going to be 10, 20, 30, 40, 50, 60, 70, 80, blah, 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 blah. And then rulers, 6, 12, 18, 24. Well, kind of rulers, you know that if diaries goes up by 12, 6 goes into 12, doesn't it? So all of these numbers here are going to be in the 12 times table. So actually we can kind of just forget about the rulers for now. Then we can say, well, what's the lowest number that goes into 12 and 10? In fact, the lowest number that 10 and 12 go into. And I think it is 60. Okay, but that's not the question. So it says work out the smallest number of boxes of each item. So how many diaries is that? Well, it's 1, 2, 3, 4, 5 boxes of diaries. How many pencils? Well, it's going up in 10, so it's going to be 6 boxes of pencils. And then rulers, well, that's going up in 6s. We're trying to get to 60, so it's going to be 10 boxes of rulers. Okay, 22. Work out blah 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 2/5 or 5/8, which is closest to a half. Easy peasy. When you're comparing fractions, you need to make sure that the bottom number is the same. So 5 and 8 both go into 40. Times this one by 8, you get 40 as the denominator. Times this one by 5, you get 40 as the denominator. In fact, let's do it for half as well. So 1/2 is going to be times that by 20, you get that. Times that by 20, you get that. Times that by 5, you get 25. Times that by 8. Okay, so we've got 16 over 40. Then we've got 20 over 40. Okay, so this is a half. This is 2/5. And this is 5/8. Okay, so which one's closest? This one or this one? Well, that's 4 away, and that's 5 away. So this one must be closest. So 2/5 is your answer. How are we doing? So 23. The scatter graph shows the number of driving lessons and the number of tests needed to pass by 10 people. What proportion of the 10 people passed on their first test? So let's just check. We've got 3, 4, 5, 6, 7, 8, 9, 10 dots. So we've got all of the people there. What proportion passed on their first test? So looking at the graph on the y-axis, how many took one test only? Well, it's 3 dots. So it's going to be 3 out of 10. Well, that's it. B, describe the correlation. Slopes upwards, so it's positive correlation. That's fairly straightforward. You just got to learn that. And then C, use a line of best fit to estimate the number of tests needed to pass by a person who has 50 lessons. Okay, so what you need to do, you've got your graph like so, you've got your crosses, blah, 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 blah. Okay, like this. So your line of best fit, let's put a few more points in. Your line of best fit is going to look something like this. So you're going to have to draw that on. And then you need to go across to 50. Draw a vertical line up to where it hits your line of best fit. Draw a horizontal line. And then you want to read that value off. Okay, so that's how you do those questions. Line of best fit, 50 lessons. So work out which side that is. So x-axis in this case, draw a line up, draw a line across. And it's important that you draw these lines on. Okay, use a ruler, not what I've done, use a ruler to your line of best fit and then just be really accurate. Are there any more? 23D. Mira says, I can use the trend to predict the number of driving tests needed to pass for any number of driving lessons. So for any number of driving lessons. Does this work forever? No. Well, we don't know, do we? So what we can say, and the posh word for this is, there is a danger when extrapolating. Right? That basically means outside of this given data range, we don't know what happens. It might go down, it might go across, it might go up, it might get steeper. We're not sure. So we can say the line of best fit may not continue in the same direction. And then we've got to say no. In fact, it's not really a question, is it? We're just commenting on a statement, so that is okay. 24. These questions are a bit weird, but actually, once you've seen how to do one of them, it's okay. So it says, on the diagram below, shade an area represented by the following expression. Well, AB is just a rectangle that's A wide and B up. The area of that would be AB. So you just need to work out on your triangle, on your shape, which one looks like AB. Well, it could be this one, or it could be the one at the bottom. So it's this one, or it's this one. You only need to shade one of them. You can only shade one of them, otherwise it would be two lots of AB. And then on the diagram below, shade an area of AD plus CD. Okay, so we've got our strip again. We want a rectangle that's A wide and D. So that's AD, because this length is A and this length is D. And CD is going to be one of these ones on the left or the right. Okay, and then you can't see that. So that's AD. And then we've got one on the left or one on the right. So I'm just going to choose this one. For C, on the diagram below, shade D brackets A plus 2C. Okay, let's think about this. So D brackets A plus 2C. Well, that's C, that's A. So the whole length is A plus 2C. And that length is D. So it's just going to be the whole middle strip. Let's see if I can squeeze this question onto the bottom. Right then, expression shape. Well, then we can be quite clever. From the previous question, D brackets A plus 2C is the whole thing. This one we worked out was AB. We need two lots of that. So I can just write two lots of AB plus that middle bit. How are we doing? So 25. Who won the race? So the person who won the race goes the distance in the shortest time. So who got to the distance in the shortest time? Ben. And then B, in fact, says who. What's the reason? Took shortest time for the given distance. B, describe the race. Well, woolly question that is. Okay, so with a distance time graph, the gradient of a distance time graph is the speed. So actually, one of the things, this is awesome, I was taught this one. So distance time, speed time, and then acceleration time. If you go from this one, the gradient of a distance time graph gives you the speed. And if you had a speed time graph, the gradient would give you the acceleration, right? And then you can work the other way. Area under an acceleration time graph gives you the velocity, which is just the posh word for speed. And the area under a velocity time graph gives you the distance, right? If that's gone over your head, don't worry about it. But basically, with a distance time graph, the steeper something is, the quicker they're going. So who starts the quickest? Well, Alan starts quickest, brackets, steepest gradient. He then stops, because if you see his graph goes horizontal, which means his distance isn't changing, but time obviously carries on. So Alan then stops. He then starts again at a slower speed. How do we know it's a slower speed? You should be able to see that the gradient is shallower. Gradient is now shallower. Where does he finish? He finishes joint last with Carl. Right, let's talk about Ben. So Ben starts fairly quickly. Steep gradient. Just such a long-winded question. Right, slows down slightly as it gets a bit shallower. Shallower gradient. I'm always like an essay. Don't worry, you don't have to write all of these down. It's just I'm writing pretty much everything you could. He then speeds up because it's the steepest, isn't it? He then speeds up, steepest gradient to win the race. This race is riveting, honestly. It's like the Olympic final. So Ben then wins the race. Carl starts slowest, flattest or shallowest gradient, speeds up and joint last, third, in fact joint second, let's be kind, with Alan. As you can tell, I probably should have been a sports commentator because that was so thrilling. Right, 25, nearly done. So 25, two straight lines are shown. A is the midpoint of OB, but let's just work that out. So if we've got that one there, and then we've got that one there, so that's O, that's B, that's 7, 6. If that's the midpoint, can you see that this one must be 14, 12? Because that's 7 across 6 up, so another 7 across 6 up would be there. This point here, somewhere here, is 25, 4. Work out the coordinates. Is B the midpoint of TS? Yeah, perfect. So how do we get from 14 to 25? Well, we're going back 11, aren't we? So then if we go back another 11, this one must be 3. From 4 to 12, we go up 8, go up another 8. It's going to be 320. So 320 is our answer. Okay, number how many left? 3 questions left. Oh my word. So 27. 27. 3 straight lines are shown. Blah 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 blah. Now we know that these two are parallel because of these little arrows. So we know that this angle and this angle. Well, that angle is the same as that angle because they're vertically opposite, and that angle is the same as that angle because they're corresponding. So we can say that they're the same. So you get 1 mark for saying 2x plus 15 equals 3x minus 38. And then when you've got an equation with an x on both sides, the trick is to get rid of the smallest x first. So 2x is smaller than 3x. So let's take away 2x from both sides. So we've got 15 equals x, take away 38. And then just add 38 to both sides. Fairly straightforward. You get x is equal to 53. So the trick there was to spot that they were equal, make them equal to each other, and then take away the smallest x first. Right, so that is how you do that one. 28. Oh, simultaneous equations. So 2x plus 3y equals 15.5. X plus y equals 6. Work out x and y. So what you do with simultaneous equations is you label your equations 1 and 2. And then we're looking to see is the number in front of x or y the same. And in both of these cases it's not. So what can we do to either of the equations to make that the case? Well, what I'm going to do is I'm going to see if I double equation 2, then I'm going to get 2x as well, aren't I? So I'm going to get equation 2 and I'm going to double it to give me equation 3. So 2x plus 2y equals 12. Now can you see that we've got a 2x and a 2x? So what I can do is I can basically take one away from the other, and these are going to disappear. So looking at these values, 15.5 is bigger than 12. So I'm going to do equation 1 take away equation 3. 2x take away 2x is nothing. 3y take away 2y is 1y. And 15.5 take away 12 is 3.5. So we've worked out y, but we need to also work out x. So which equation is easiest, 1, 2 or 3? Equation 2 is probably easiest. So substituting it into equation 2, x add y equals 6. Well, y is 3.5, so x should be 2.5. So we've got y is 3.5 and x is 2.5. Happy days. Are we on the last question? Hurrah! So let's go up here. 29. In the diagram, the area of triangle ABD is 56 centimeters squared. So AB, let's just draw this out. So we've got A, B, C, D. These are right angles. That's 6. That's 14. ABD area is 56. Let's draw that out. That's 14. We don't know that length. We're trying to work that out. Work out the length CD. So we want to work out that length. Okay, so what we need to do to work out that length, we need to work out the height here. So if the area of this, the area is half base times the height. So 56 equals half times the base times by the height. Half of 14 is 7. So 56 equals 7 times the height. So the height must be 8. So then if I draw out my second triangle, I've then got BCD. That's 6. That's 8. And now I want to work out that length. So we've got two sides of a right angled triangle. We're trying to work out the third. So we use Pythagoras' theorem. A squared plus B squared equals the hypotenuse squared. Hypotenuse is the side opposite the right angle. And A and B can be either of these. So let's just say 8 squared add 6 squared equals our hypotenuse squared. 64 add 36. This is going to work out quite nicely. X is the square root of this, which is 100. So we've got X must be 10 centimeters. Perfect. So I hope that that has been useful. If it has, drop it a like, subscribe, and have a good rest of the day.